This video will review how to graph factored polynomials. So what we are going to start with is you're going to be given a polynomial. In this case, it is factored for us already. And we are going to determine the zeros of this polynomial. And we will count the multiplicities. What multiplicities are is like how many times is that zero occurring, and we will see when that happens. And then we will graph the polynomial based on those zeros or based on those x-intercepts. So the first thing you want to do is replace f of x with just 0. And set each factor equal to 0. So x equals 0 is one of our x-intercepts. X equals positive 1, x equals negative 1. So in this case, we have 3 zeros. And so then we can go ahead and just sketch a graph. Now this is a sketch, meaning it is not exact whatsoever. But the main piece is that at each of these x-intercepts, which they're very close to each other, we have and we can just sketch a little something like that. So if we move on to the next example, this is where it gets different because this is now saying we're given a polynomial with 4 terms. And if we are told that we know that x minus 4 is a factor, then that means that it divides evenly into the polynomial. So you can either use reverse box method or long division. I'm going to just use long division. Make this a little smaller. There we go. It's going to divide into So if you remember from last unit, our first step with long division is how many times did x what does x need to multiply by to get to x cubed? That's an x squared. So we multiply through and we end up with x squared. X squared times negative 4 is negative 4x squared. We subtract. These now cancel, and so negative 13x squared minus a negative 4x squared, that really turns into a plus. So we end up with a negative 9x squared. We carry down our 44x. And so now we look. X times what gets us to negative 9x squared, and that's going to be a negative 9x. Now we multiply through. Negative 9x times negative 4 is a positive 36x. We subtract. These again cancel. 44 minus 36 is an 8x. We carry down our negative 32. X times 8 will get us to 8x. So we get an 8x, we have a negative 32, and when we subtract, we end up with 0, meaning that yes, indeed, it was a factor. So now we have this new trinomial of x squared minus 9x plus 8. You can think of that as after, it's the original after x minus 4 has been divided out, or after that has been factored out. We can then continue to factor this polynomial. So if we use our x factor method, we're going to add to a negative 9. We're going to multiply to a positive 8. So we can think about, well, we know 8 and 1. They both need to be negative. So we have x minus 8, x minus 1. So if we were to look back at the original and we wanted to write that as a factored form, that would end up being, well, we have both of these factors here that we just had of x minus 8, x minus 1, but then we also have that x minus 4. So this right here is our factored form. Then it says to find the x-intercept. So we are basically just going to take each of those factors, set them each equal to 0. Solving for x in each of them. And there are the x-intercepts. So if we go down, it says at which x values can the function change from being positive to negative or negative to positive? Remember what negative means is below the x-axis, or the y values are negative. Positive means above x-axis, or where all of our y values are positive. And where this can all occur is at the x-intercepts. And another word for that are the zeros. We will sketch a graph of this, but we need to consider what the graph is going to look like for these 4 intervals. And the reason why we need to do that is because we need to figure out, is this graph going to fall above or below the x-axis? So I'm just going to write, well, graph the above or below x-axis. And we can tell that by testing values. So for x less than 1, so you can choose any x value that is less than 1. I'm going to go up, make sure I'm rewriting the polynomial correctly. So we have x cubed really want to double check there. And I'm going to choose any x value less than 1. So let's choose 0. It's an easy one. The reason why that's pretty easy is because now we've got 0 replacing all of these. That means f of 0 is negative 32, meaning it is going to fall below, or be negative there, because it's a negative number. Again, we're going to do the same process for all of these intervals. So for the next one here, I'm going to choose the number, let's see, let's try 2. Again, you want to make sure you always put parentheses around when you are substituting in. And you can go ahead and calculate that. And we do indeed end up with a positive 12. So that means it's going to fall above. Same process again. Let's try 5. we end up with a negative number, meaning it is going to be below. Notice there's a little bit of a pattern going on, so you can go ahead and take a guess as to what's going to happen in the next interval, but you really do need to go ahead and solve that through all the way. Let's try 10. And we do end up with above. So we're going to use all of these key pieces of below, above, below, and above to sketch a graph of this. So if we come down, I'm going to set up my axes. And you need to start with the x-intercepts. So if you can't remember what ones we had, you're going to go back up, and they're coming right from this part here, part B. So we have 8, 1, and 4. So I'm going to go on my x-axis, and I'm going to place a point on 8. There's 1. There's 4. There's 8. And then we're going to look back at those intervals, and we have below, above, meaning we have to start below the x-axis, and then we go above, and then below, and then above, and we have sketched a graph. Again, it's a sketch, so it is a rough sketch. If you were to graph this on your graphing calculator, you would see a very similar curve to the one we have here. That is how you graph factored polynomials.